Did I miss something? I can't hear you at all.
I think he was talking to someone that is in the office.
I was talking to him. Okay. Kayla, talk to me about 10.3. What, let's see, what is it saying? Oh, like note 10.3, this thing here, it's the same thing that we have going on here. So when it says, why do we not have an actual number? They're referring to the fact that they're just saying it's less than 0.00001. I guess, what do we say here? The number is super duper, 10.3. Okay, Kayla, I could try to read a little better. Okay. So two things on this one. First, we're reminding you of a special name for the type 1 error. That's a false positive. Does anyone remember what's the probability of a type 1 error equal to?
Where are you? What worksheet? What page? I don't.
10.3, page 699.
Okay.
We're doing Kayla's question.
Oh, if A is 0.3, what is the probability? You know what? I didn't get that either. That's the one I didn't get.
Well, good. Two birds, one stone. So if you look at your 10.3 notes, there's one page in there where it discusses alpha, beta, type 1 error, and type 2 error, like all of that stuff. And the thing you need in your reference sheet to keep track of this is that the probability of a type 1 error is equal to alpha. So we select alpha and we're like, hey, what's the chance of a type 1 error? We're going to set it at alpha. So the answer to number 3 is 0.03. When we tell you the number for alpha, that's the probability of a type 1 error. For beta, that's the probability of a type 2 error. That's this one. That's equal to beta. We don't talk about beta other than the relationship between alpha and beta. Like, we don't show you how to calculate it. It's a little bit complicated. No worries, good. Just remember this, if we increase alpha, so if we make alpha larger, we decrease beta, which I think we talked about Monday when we did B here. Okay, so then number 4 is a tricky one.
Can I ask a question really quick?
Oh yeah, please, go ahead.
If alpha goes up and beta goes down, is that still a type 2 or is that a type 1?
So this is just the relationship between the two. Alpha is the measurement of type 1, beta is the measurement of type 2.
Okay.
So another way to think about this is if we increase the chance of a type 1 error, we're going to decrease the chance of a type 2 error.
Okay, okay, thank you.
You're welcome. It's that seesaw thing, kind of like what some of the stuff from chapter 9 was like that. Okay, so for 4, we're saying which of these can't be it. If you grab your reference sheet and look at any one of like page 275 or 276, and you look at the graphs at the bottom, this is the only graph that doesn't work, that you don't see. And that's because all the areas are on the outsides. This graph is, someone probably did this one wrong because this area is really, really large. So it's unlikely that you would have a right tail test where you would have a negative t-value. That's what's happening here. We got a t-value below 0. But it's still a possible output from StatCrunch. But for this between one, you're never going to see that. You will only see area here. You can't see my screen, of course. Okay, so I was talking about this letter B. This area is possible, but it's most likely you did something wrong. This would be a right tail test, when maybe it should have been a left tail test. So someone entered it in StatCrunch wrong, but this one can't actually happen. Because the area is always on the outsides. Does that help? Let me see. I think somehow I lost my chat when I did that. Can you see my screens?
Yes.
Yeah, we can now.
Okay.
We didn't for a long time. I thought it was a new thing you were trying.
Yeah, right. Let's see if they can guess what I'm talking about. Sorry, I'm at my office. I haven't done a Zoom thing here, and I have 2 monitors. That's why I'm like looking different ways too. So it's yeah. Okay. Good questions, y'all. So let's jump to 11.1 then. So the first thing.
Can I ask something just really quick? I'm sorry, but on the bottom, on number 4, the following 3 shaded T distributions, the shaded area represents probabilities. Which of these the sketches can't represent a p-value? And is it C because a p-value can't be between? Oh, you see it. Okay, got it. Sorry, I didn't look up. Thank you.
You're good. That's what I was like. That's what was talking about, but was hidden. Good. Okay. So 11.1 worksheet number 2. I like this starting spot because what gets challenging with chapter 11 is that we now double all of the information because we're working with 2 samples. And one of the things you looked at in 1.6, I'll jump to the 1.6 worksheet, is that you have to determine if you have 2 groups measured once or 1 group measured twice. That was
so Eric, just to let you know, we did not actually do the 1.6 notes, but we did talk about like the 1 group, 2 groups when we did the 11.1 notes.
Perfect. That's all we need.
Yep.
Perfect. So when you're working with a proportion for this class, it's always independent sampling. Every single time. That's the only ones we do. So we have 2 groups and we do a measurement from those 2 groups once, and then we compare the results between the 2 groups. What we're trying to do is see a difference between, like, the grouping is what we're looking at. Like, for example, this question is looking at the difference between men and women in terms of who uses fitness trackers more often. Right, so here's our problem. We got this Pew Research wants to discover if there is difference in the percentage of fitness trackers for adult men and women in the US. So they get a random sample. Here's group 1 of US men, and then a random sample of US women, and here's the results. So when you look at the reference sheet, I got to get this pulled up. Okay, let me just download this thing. The step 1 of the hypothesis test is the most challenging part of these problems. I think it gets quite difficult, and you have to pay close attention to all the details. So if you want to think, if you're looking for a difference between 2 things, you're doing subtraction, right? So what we're doing here, if you note, we're doing men minus women. Now, What if those were the exact same thing? What if it was the same percentage? Like, what if 50% of men and 50% of women used the Fitbit? What would this subtraction equal?
0.
Wouldn't it?
That's it, 0, right? Nailed it. So that's the key thing in all of chapter 11 is we're comparing two things, we're subtracting them, and either we're going to get 0, or we're going to get a number greater than 0, or we're going to get a number less than 0. It's the key.
So Eric, when I had them write the null hypothesis, I actually had them write it as P1 minus P2 equals 0
Nice.
instead of the P1 equals P2.
I love
I
it.
said it will make more sense, and it's that way in StatCrunch. So
Yes,
I guess I was reading your mind.
you were. I love it. It is always confusing with like the equal and then, yeah. So that's what is this? Just so that's the key. And then even with confidence intervals, it's the same idea. If we create a confidence interval, we're looking, is this 0 within the confidence interval? If 0's in there, then there is no difference. Okay, so then there are the 3 hypotheses, right, that you all talked about yesterday. If we're just talking about a difference between the two, we don't care which one is doing more than the other, just that it's not a 0. Or maybe we're interested in there were more men doing the thing than women, or there were less men than women. That's all based on the subtraction, the direction you subtract it. So I want to see if you all can fill out this information here just from the output. See if you can't fill it in.
All right.
And it's all just to let you know, it's all right here. Okay. Does everyone understand what this little subscript means?
No, because that wasn't in our notes. So that's kind of, is that like the 1 and 2?
What would you guess M would reference?
Probably 1.
And what would
Men.
W? Good,
2.
Peg. I like that better, right? So, right, men is group 1. So
Oh, duh. Okay.
it's okay.
Duh.
No, it once you see it, you see it. That was what was in the head of whoever wrote this worksheet for us. Okay, let me give you 5 minutes and you see if you can't fill out A and B. So the timer for 5 minutes. And don't be afraid to ask questions. That was 5 minutes. So, how'd y'all do? Did you get 350 here and 460? And did you remember how to calculate p hat?
No to both. And I,
Isn't p hat x over n?
Yes.
Yeah.
So Peg, when you said no to both, did that mean you didn't agree with the 350? So where I'm getting them from, so this is the weird thing, right? StatCrunch does counts 1 and total 1. And the way StatCrunch works is count is X, but it also calls it number of successes, like the one we just did, right? And then total is N, but it's also called number of observations. So this was the X1, N1, meaning the stuff from group 1, which means this is X subscript M, N subscript M, which is kind of annoying. Like notation is so important. I think this is a great example of how the notation can kind of get in the way of things. So how are we doing with this? 0.18. And then this would be X2 or X subscript W and N subscript W. So 115 over 460. I just cannot tell if you all can see. You all just shout it. If you suddenly can't see things, just shout at me. How are we doing?
I missed our notes stuff yesterday, so I'm following along, listening and taking notes on my notes and trying to do the worksheet too.
same here.
Okay, good. Well, so I think one of the nice things here is there's not too much new stuff here other than this subscript business. And understanding how these subscripts work is really important, especially because even within this one problem, we have 2 different subscripts, 2 different ways of naming things. Okay. Confidence level, do you remember that from confidence intervals way back in chapter 9?
Would love a review.
Right here. The way we state the confidence level with respect to confidence intervals, or the way StatCrunch is 91% confidence interval. That's the language we use, but that percent is the confidence level.
I didn't even see that. My apologies.
No worries. Nope. That's what this is about, is practicing reading this mess. I mean, it is a lot to read, and getting good at reading it is important. Okay. Confidence interval. Remember, that's lower limit, upper limit. Part of this, by the way, is it's been a bit since we've done confidence intervals. That was all chapter 9, and suddenly here we are doing some in chapter 11. So here's the confidence interval. Lower limit, this number, upper limit, this number. So in this case, it's negative 0.119. Oh, we're supposed to do 4. 188 up to negative 0.0212. Quick conceptual question. Let me remind you that the way we did this subtraction, it's stated right here, is we did the men usage minus the women usage. The percent, right? Looking at the confidence interval, who's using Fitbit more, men or women? And how do you know?
No idea.
Good, glad to hear. Does everyone have no idea?
Well, yeah, I didn't really even understand the question. How do we know by the confidence interval, who uses more?
Right, so what we're doing is we're taking the percent of men that use it minus the percent of women, and we're
Right.
getting some sort of number, right? And we agreed that if this was 0, it's
Are we doing the at 0.18 minus 0.25?
that's one way to find the point estimate, but remember the confidence interval tells us where the population value is. It's somewhere in between. So if we think about what this is, it's somewhere between negative 11.88% to negative 2.12%. So who's using it more, men or women?
Men,
Okay, why do you think men?
because on the one on the men, it says 91%, and the confidence interval for the women, 91% blows it out of the park.
Okay, let me change your all's thinking. Remember the direction we're subtracting the percentages. So we took a sample and we're like, hey, 70% are men, of the men are using it. We took another sample of the women and we said blank percent of them are using it. And then we subtracted the two, right? We said, really what's happening for the point estimate, we took the 0.18%, which is the men usage, minus the 0.25%, which is the women usage, and we got negative 0.07 from our sample. And then around that sample, we built this confidence interval. That's this. The fact that both of the numbers are negative tells us the women are using it more than the men, because when you subtract two numbers, if the number you're subtracting is bigger, the absolute value is bigger, you'll get a negative value. What do y'all think about that mess?
So Eric, for that one, I did the lower limit, upper limit minus lower limit divided by 2. Is that not?
That's the same thing? Yep.
It is, okay. But you didn't divide by 2.
Yeah, that's what I did, and you didn't divide by 2.
I didn't use the limits. I used the P.
Okay, okay, got it. That makes more sense.
You'll get
Got
the same answer, or roughly,
Yes.
right? So
I see.
maybe we should have done, maybe I should have started with a quick review of confidence intervals, just generally speaking, right? The way they're set up is you have a lower limit, lower limit, and you have an upper limit. And then in the middle is the point estimate, which is the statistic. So in chapter 9, when we messed with this, it was always just the p hat from the sample or the x bar from the sample. But now that we're working with two samples, it's the difference between those two sample values. So it's literally the p hat for the men minus the p hat for the women. That's our point estimate. But just like you all pointed out, we can calculate that using the upper and lower limits if we know them. So either direction is fine. This is an old school question, margin of error. Did anyone remember the formula for the margin of error? Actually,
Yeah, it's
Isn't it the, yeah,
Re-
the,
reverse of
between.
point estimate. It's just you add them.
yeah, add and divide by 2. So we're going to add together these 2 point estimates. I guess we're supposed to use 4 decimal places. So I'm going to ignore the negatives. Since they're both negative, we can do that. 1.8 plus 0.0212 divided by
Wait a
2. Oh, wait a minute. Are we sure it's that?
No, I thought it was the 18 and 25 that we add together, and then that's our answer.
No, because these are the p hats from each sample. So we've actually got the formula backwards. The point estimate is calculated as the sum divided by 2. The margin of error is the difference of these two values divided by 0. Divided by 2. Sorry. So it would be 0.0212 minus negative 0.1188, and all that divided by 2. So in other words, the top, this difference, this subtraction, is the distance between the limits, called the width. When we divide that by 2, we get the distance between the point estimate and either of the limits. So up here, we should be adding the 2 limits together and dividing by 2. That gets us our point estimate. Down here, you should be subtracting. This is a good one to do in Desmos, especially with those negative numbers that can mess people up. Unless you're good with like minus and minus is plus. This is our margin. 0.4. Always a positive number, by the way. How are we doing?
So for the point estimate we add. Okay, got it.
Because it's the average, it's the mean between.
Mhm. And then the bottom subtract, got it.
Okay, B is a nice old school problem. Do y'all remember how to get the critical value in StatCrunch? So in StatCrunch, you could look at your chapter 7 reference sheet material. We're going to use this confidence level, and it's the between for the normal calculator. So this is going way back in time, way back to chapter 7. We also did it in chapters 8 and 9. So you go to normal, and we use the confidence level area for between. Since it's a z value, a critical z value, we know the mean is 0 and 1. There they are, plus or minus 1.695. Like shading, you could shade either way. This one is not as, it's not like p-values where it has to be shaded on the outsides. You could shade the between and that'll be okay too. Like the shaded between is 0.91. These outsides are the alpha. So that would be 0.09 that's being split into each of these areas. Now, this alpha is a little different than the, it's not a type 1 error alpha. It's what we use for the critical z value. Okay, how are we doing with that?
Hang on, I've got to look at this again.
Yeah,
So we're using the confidence interval when we put it in to StatCrunch, right?
yeah, you're using the C level.
And we're using the decimals,
What do you mean by decimal?
not percent. You know, I would put
Yeah,
in
yeah,
0,
the
2, 1,
0.9%,
2. Yeah.
right.
I would put it, okay, so
Here's, sorry, I
I
clicked.
did not
here's
get what you got at all. That's why I'm asking.
Did I answer it? I'm sorry, I think I cut you.
No, not at all. Because
Okay.
I didn't do it right. I needed to put in the 91%. I made it way too hard on myself.
No worries. And you click
Got
the
it.
between and then the on the right side.
I got it. Yeah.
Nice. Okay, are we ready for the next bit?
Ready as I'll ever be.
Nice. Okay, sorry, I'm trying to pull up the reference sheet material. All right, so this becomes quite a bit more complicated because you have to do it twice for all four, well, no, for the three options we used to do before, and then there's one new one you have to note. So let me, I don't know why I can't find this thing. Let me pull it up. The new condition is determining or stating that you recognize whether the samples are independently drawn or dependent sampling. So like what you did in the notes last night. Here we go. This would be, I think the order we do it, like, so C1, we have to show that sample 1 is random and sample 2 is random, right? So like you could say the random min, that's given, and random women, that's given. Right? How do we know that? It said they gather a random sample of adult US men and adult US women. So there's your two different samples. Now, condition 2 is the sampling type. And I want to open this. Here we go. I believe this is, here we go. So here's what it is. Are the samples independent of each other? So this is just a one thing. We're looking at our two samples. Did we draw them independently? So in our case, they are, because we have two groups measured once. So here's how I like to have students write this one out. You say independent samples. And then your proof, in this case, two groups measured once.
I totally read your mind. That's exactly what we wrote.
Nice. And then if it's the other one, it's one group measured twice. Yeah.
Yep.
That's the test of what type it is. Okay. So then the next three, C3 is independent within each one. And then C4 is normal within each one, right? So you have to do two things. You have to show that N1 is less than or equal to 0.05 of N1, capital N1, and N2 is less than or equal to 0.05 of capital N2. So it's a bigger, like it's more work, unfortunately. The nice thing is it's not any different work than what you did. You're just doing it twice for each problem. And then same thing for the calculation of normal, you need to show that N1 times P hat 1 times Q hat 1 is greater than or equal to 10, N2 times P hat 2 times Q hat 2 is greater than or equal to 10. So that's where, like here, we have it NW or NM and NW. Here's our two N's that we're going to use. What's unfortunate, or maybe fortunate, is that the population these two samples are drawn from are the same population. Although technically they're not, because it's all men versus all women. So it's a little different. So for the men, there were 350 men. We're showing that that's less than or equal to 0.05 times all men. Apparently there's 101 million. Check, that's good. Don't worry about calculating that. That's sample 1. Sample 2 is the 460. And that's 0.05 times the women. 100, fail. And I'm out of space too. 108 women. Check, that's good. How are you all feeling about this? Is this kind of making sense?
It makes sense. It's just a lot.
Yeah, it's just extra steps, but it does make sense. I think just because we've had so much practice with the chapter 10, it kind of just comes natural a little bit.
Good. Like, you know it. It's just, ugh, here we go. So when you do project 11, you need to have all 4 of these, and you're comparing your Skittles and M&Ms. So this is exactly what you'll do for one of the questions in project 11.
So Eric, we still have not gone over project 10 yet.
Oh, no worries. Maybe I should plan on doing that on Monday.
Okay, can we just go over the normal again?
Yeah.
That's just right over here. What's the? Oh, we're doing okay. It's the same thing. Got it. Thank
And
you.
You're welcome, although I didn't do anything. What's unfortunate is these ones don't match the labeling we used in part A, right? The 1 should really be M and the 2 should really be W. We should have picked a lane and stayed in it. Okay, I'm gonna rewrite the confidence interval here. I want to give you all some time to think. I want you to think about question D, and then I want you to think about question 2. And I'm going to give you like 5 minutes to think about it. What I want to know in question 2 is, what are you being asked to do in question 2? So let me give you 5 minutes. See if you can't come up with the answer to D, and maybe the whole answer to number 2, and then we'll check in. Set a timer for 5 minutes. Okay, y'all. Is there a significant difference between the proportion of US and adult women? So what's your answer to D? And if you have no clue, I'd love to hear that too.
So for those of you that were not in class last night, remember you're thinking about whether 0 is inside of your interval. Is 0 contained inside of your interval? If it
No,
is,
it's not.
okay, so if it's not, then there is not significant difference. Or there is, sorry. That means there is. So if 0 was, there would not be significant difference. Because
Right.
0 is not, there is significant difference. So we don't want to have 0 in there.
Does that make sense, you all?
Yes, because everything's always opposite in math.
Well, so remember the reasoning here. If there was no difference between men and women usage, then when we subtracted their numbers, we would get 0. Right? So it doesn't actually matter that our two numbers are negative. What matters is that the 0, like if I draw a number line, here's negative 0.02, like here's 0, here's negative 0.1188. This is how we know women use it more than men, because it's a negative proportion. It's the difference between these two is negative, and so that means the women usage is higher. Had we changed the subtraction, if we had done women minus men, it would just flip this across the axis, and we'd be at 0.02 and 0.11, and it would show the exact same thing. Women use it more than men. It's just, it would be a positive number. So that's the point. As long as 0 is not within the interval, there is a difference between the usage or whatever's happening between these two samples. So this is the much easier one to evaluate a claim. Remember back in chapter 9, you had to figure out, is the value in the interval, below the interval, above the interval? Were they claiming above, or were they claiming below, or were they claiming within? So it was much more complicated to show support or contradiction using the interval. Now it's very simple. Is 0 there? And here's the thing. If both numbers are negative, 0 is not in there. If both numbers are positive, 0 is not in there. If the numbers are different, if you have a negative number, then a positive number, 0's in the interval. Okay, how'd you do on number 2? What are you being asked to find? What's the question in number 2?
What is the difference between research, the proportion of US? Okay. What is the difference between people ages 18 to 24 and people 25 to 34 on how they use Twitter every day?
Love it. Now, that is the thought. That's what the researchers are asking. What am I asking you to do in the worksheet?
I have no idea. And I just, because I haven't listened to any notes, so I feel like I don't even know what.
It wants the formula, the substitution, and a result.
Read before that. Because is it a confidence interval, a verify the requirements, a hypothesis test, or a sample size? Right? Those are the 4 questions we're going to ask you. So you all just keep reading. It's, what is this sentence say right here?
Well, it's a proportion.
How many?
How many? Ooh, that's a key word. What does how many tell us to do? Let's see.
How many people from each age group must be sampled?
Yeah, see this? This is page 274 on your reference sheet, the how many question. It's calculate a sample size. Note the clues to the fact that this is where the question is. the question mark. That is one of the big clues. Here's the sentence where I'm giving you the command to do something. And the how many is telling us what you need to do. So where it says show formula, let's see. Peg, you mentioned this. This was good. It's a proportion. So we go to our how many thing on page 274. We note that when we're working with a proportion, it's either going to be one of these two formulas or one of these two formulas. So let's go back. You also mentioned, Peg, which was good, that we're comparing 18 to 24-year-olds to 25 to 34-year-olds. That's two samples.
Right.
Do we all agree about that?
Yeah.
Yeah, and they're independent, right? Like we're not saying brothers and sisters that are or siblings that are in these different age groups. It's just one group that's 18 to 24, one that's 25 to 34. So since it's two samples, we are going to use the double population sample size formula, not the single population sample formulas. So it's not these two, it's one of these two. Now, look at what these two have. Oops, I got way too much highlighting. It says either a prior estimate or no prior estimate. Which does our problem have? A prior estimate or no prior estimate?
No prior estimate.
How did you know? You're right. How did you know?
Well, because it says how many people from each age group must be sampled to correctly gauge the difference. So that
Good.
means they haven't done it yet.
Yeah, and there's no percentage there, right? If it
No.
had said, hey, last year, 15% were from 18 to 24 and 32 from 25 to 34, there we would have a prior estimate. There isn't one. All right, so that's fortunate because this formula looks way better than this formula, right? So we're going to copy that down. We're going to say that the sample size for both, so the sample 1 size and the sample 2 size, they're going to be exactly the same. And we're just going to use the 0.5 times the critical Z value divided by the margin of error squared. Let's make sure I got that right. Yes, 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 yes. We're good. Okay, can we find all these things? Do you know how to find them? Let me give you 3 minutes to find them, and then we'll check and see if you actually found them. One of them you need to do in StatCrunch. Set a timer for 3 minutes.
I think I'm ready.
Okay, let's do it. So let me start with the one. Oh, okay, perfect time. What'd y'all get for E?
Would that be the 0.022?
Nailed it. Now, did you change it to a decimal?
Well, yeah, it's 0.022. That would
That's
be.
exactly what you said. Why would I think?
Oh,
Nice, Laura. Yeah, right?
don't throw me off like that, Eric. I'm not
All right.
ready, okay?
My brain was just like not really engaged for some reason. Okay. How did you get the Z alpha divided by 2?
I went to StatCrunch and did stat, calc, normal, pulled that open. Yep, 0.92.
Love it.
And then I just substituted it all in and did it in Desmos.
Excellent. Is everyone clear that we had to use the 92% with the between?
Yeah, that's what I did too. I went one more decimal. I just used the whole thing.
Okay.
Which I might have gotten a little bit different answer.
It's slightly different answers.
That's what I did too. I used the whole decimal on the.
Perfect. As long as you're writing down what you used, you're good. So let me make it, I'll use the same thing. I think my math lab will tell you to round to 3 decimals. I think that's the more common thing. But for my grading purposes, I'm happy with whatever you do. Awesome, good. And what number did y'all get?
3166.27.
3166.27. So the correct answer is
367.
nice. Always
Or
round up.
3167. My bad.
Always round up when calculating sample size, which is different than just rounding.
I got 316.627. I got like 1 decimal to the side, to the left. What did I do?
So, something you typed in was wrong.
I don't
Did you forget the 0.022?
know. I have 0.022. I don't know. I mean, I must have done something wrong, but mine looks the same. I don't know.
Did you use 0?
Oh, you know what? I put 0.05.
I was just gonna say.
My decimal went in the wrong spot. So that's
Okay.
what it is.
So 0.05 instead of 0.5. Good.
There we go.
Okay.
Yeah.
So what we've practiced here is a confidence interval of independent sampling with proportions and a how many question. We've also done a verify question. So the one question we haven't done is a hypothesis test. So I want to throw you to the wolves and have you do the one on 712. So this is the steps 1 through 6. In other words, when we get over here on page 277, you're going to be doing this whole thing. So I want to see if you can pull that off. Note that you don't need to test the requirements unless it asked you to. And in step 3, we don't need either of these things written down. Just write down the Z naught and its p-value. I know Cindy told you that, but I think it bears repeating, right? That's all we need for step 3, because that's a lot to write. So try to get from steps 1 to 0. I'm going to give you 5 minutes. I'm going to check in to see that we all have step 1 right. If you want to put in chat to myself or Cindy or to the whole group what you think step 1 should be, so that you can keep going and get the whole thing right, do it. Okay, so let's give you 5 minutes and see how you do with question 4. Set a timer for 5 minutes. Okay, that was 5 minutes. How do you feel about A? What did you all say for that one? Let's just start there.
Independent quantitative.
I just didn't know if it was independent or dependent since both of the drugs reduce the risk, like they kind of do the same thing, even though they're like two separate drugs. I just didn't know.
So for the independence, the question is 2 groups measured once or 1 group measured twice?
So it's 2 groups measured once.
Okay, so we
Okay,
know
so it's
independent.
independent.
Now,
And-
qualitative versus quantitative, that's the tricky one.
Wait a
What?
minute, say that again. It's 2 groups measured once, so it's what, dependent?
Independent.
Independent.
Yeah, okay.
Because we're not, so the reason that sentence works is if we're doing 1 group measured twice, what we're doing is we're doing a starting measurement of a person or a thing, and then doing a second measurement sometime later. And then we're comparing the measurement of each data value in the data set. So it's like, I'm sitting here, what's my heart rate? Now I go to 100 jumping jacks, what's my heart rate? And I'm comparing my heart rate to myself. That's what makes it
So
dependent.
it's quantitative.
In this case, now, so in this case, what is it? What is the data set that we collected? Of each patient, what did we ask them? Kayla, why did you say qualitative? Like the treatment here is each person gets, 1 group gets the, I don't know how to say any of these words, the T drug, and the other group gets the C drug. And then what did we look at? What are we checking that happens?
Patients that suffered a heart attack or stroke.
That's it. So if you look at the data set,
So it's qualitative.
right, because it's either yes, they have the heart attack or stroke, or no, they didn't.
So independent, qualitative.
That's it. Now, Kayla has a really good point, and I missed that when you said proportion, right? In our class, when we're working with proportions, they're always qualitative data sets. We're just saying how many people said yes versus how many people said no. How many things met the criteria versus how many total things did we have? So Kayla's 100% correct. If your data set is proportions, you're dealing with qualitative data. So here's the correct answer for A. We had 2 groups. We measured them once, and we looked at a percentage that met a characteristic, meaning the data set is a yes or no type thing. Okay, now, how did you do with this step 1? Which of these 3 did you do? Right tail or left tail?
I did less than, because there, it says significantly lower in B.
Okay, love it. Let's check if you're right. Do you note, by the way, that every single one of these is comparing the 2 proportions? And so if we do what Cindy did, which I totally agree that you should do that, write the subtraction, and we're all comparing to 0. Back in single proportions, we always had to find an assumed parameter value. We had to find a number for the population, and that number went in here in our step 1. Now in chapter 11, when we have 2 samples, we're never putting a number in. The number is always 0, actually. Now, is this the correct thing? Now, what we need to do is make sure we understand what is group 1 and what is group 2. So it says, can you conclude that the proportion of patients suffering a heart attack or stroke is significantly lower for those receiving the T drug? So if we do it that way, what we're thinking about is T minus C. And if it's going to be lower, this should be a negative number, because this percent should be smaller than this percent. And so when you have a small number minus a positive big number, you get a negative number. Turns out if we switch the order, it would switch the inequality sign. Y'all with me on that? So
Is that something we're gonna see again, Eric? Is that the inequality sign is gonna change like that?
it's dependent on the order you do the subtraction.
Oh,
And you were not told which order to do it. Explicitly, it didn't say make the T drug a group 1 and the C drug a group 2. It just said, here's the order, write out your hypotheses. So someone could write, you could have either one of these and you would be correct. That's the unfortunate part of chapter 11.
Lord have mercy.
Oh, he does, or she does, or it does, or they do. Yeah, right. You just have to keep in mind which direction did you subtract and what was the statement. So it is tricky, but we said that the T drug is lower. So that's why doing it this way, I mean, that's why you were correct. We're going to subtract the C from the T and we should get a negative number. Which means what we have just established is that group 1 equals the T group and group T equals the C group. Is that okay? Sometimes you don't have the freedom to do that. Let me see if there's a worksheet where we tell you which direction to do it. Here's one. Here we said make males group 1, females group 2. This one lets you do it any direction you want. Here's another one, any direction you want. Here's another one, any direction you want. Here's one where we tell you what the groups are supposed to be. And the reason is because we've already done the whole thing here. Okay, so that's the extra challenge in chapter 11. You got it, we'll get this. Don't sweat it. Does everyone know step 2? Did everyone get alpha?
It's 0.01.
Love it. That's the same as all of them. And then step 3, here's what I think you should write for step 3. Let me pull up StatCrunch so you can see all the stuff we're going to have to put in StatCrunch for this. First, as a reminder, if you're using your reference sheets properly, it tells you where to go in StatCrunch. You don't need to guess. You don't need to wonder about it. It's right there. You just need to know how to read it. All right, so we're going to go to stat, proportion stats, to sample with summary. So let me go there. Here we go, stat, proportion stat, to sample with summary. Now look at all the stuff we need. Let me pause and let you catch up. I'm all over the place here, right? So we need 4 things. We need the number of successes for the first sample and the number of observations for the first sample. Number of successes for the second sample and the number of observations. It's the same thing.
Do you
as
want us, sorry to interrupt,
Go.
for that step 3, before we had to write down the formula, at least I always did, is that something you would like to see, even though we're using StatCrunch? Or
Skip
can
it.
we,
Skip it.
right? Do you want us to write it down or is it,
Nope.
okay, I'm just checking, it'll take up a lot of space.
Yep. That's why we're like, hey, don't even bother to write it. Just leave it be. It's a long, nasty thing. Throw it away. This is what it's calculating. How StatCrunch calculates the answer. So what I would encourage you to do is write down what you have to write up in here. Right. So we need X1 and N1. So we need the number of successes for the T drug and the number of observations for the T drug. And then we need the number of successes for the C drug and the number of observations for the C drug. That's what we have to type into StatCrunch. So let's find it. All right, so medical researchers performed a comparison of two drugs, blah, 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 blah. And a total of 1,958 patients were given the C drug. You with me on that? That's this one. And 1844 were given the T drug, or 1842. Of the C patients, which is group 2, 7.3% suffered a heart attack. So remember, we have to do P hat times N to figure out what that number is within 1 year. Of the T patients, 6.9% suffered a thing. So 0.069 times 1842. How we doing here, y'all? Is this getting okay, or is it getting crazy?
It's getting crazy.
Here's my like hope message. You're just doing what you did in chapter 10 twice. Right? You had to do this once for one thing. Now we're just doing it twice. We're just doing it for two things, which gets crazy because you have to track everything. You got to match it all up. You got to make sure the group 1 stuff are with the group 1 stuff, the group 2 stuff are with the group 2 stuff. This is an organization thing. So I'm going to type these in. I'm going to pause, and you all tell me when you feel ready. Great question, Kayla. So for the X rounding, we're rounding with standard rounding rules. So that 142.934, that rounded to 143. The 0.069 times 1842, that rounds to 127. So we're not calculating a minimum sample size. You got it. Nice. We're just getting the actual sample size that is used. The only other thing to note in here is that we need to change the inequality sign to match the one we've used. And it's important that whatever we put in here for sample 1 and sample 2 matches how we define the samples 1 and 2 in the problem. Otherwise, we'd have to switch the inequality. There is a way to change test 0. We don't worry about that in this class. So you're always going to leave this at 0. Click compute, and there's your stuff. So how are you all on filling out steps 4, 5, and 6?
So for step 3, we put the Z and the p-value.
Yeah.
Okay.
This is a strange a strange z-value and a strange p-value. It's not there, the p-value is quite large, right? Quite large. It makes me think I did something wrong, but I don't think I did. So I think we're okay. If you look at the sample difference between these two, so when we subtract the p-hats, it's really, really tiny. So that would explain, that helps explain why the p-value is so large.
So do we draw one graph for this? Like, I wasn't in class yesterday.
Yep.
So,
Steps 4, 5, and 6, exactly the same as
oh,
everything.
okay.
Once you get your z-value, your test statistic and its associated p-value, the rest is the same. So the right tail graph, although really it looks like this, because there's so much area to the left of it. Step 5 is the p-value less than alpha. So 0.312 less than 0.01, far from it. So do not reject HO. And then step 6. There is not sufficient evidence to support the claim that the T drug is significantly lower. Okay, great. One of my favorite questions. If the above error was incorrect, what error did we make? If it had been the incorrect decision.
Type 1, because that means that it doesn't lower heart attacks and then you're giving it to people. So it's like the, oh wait, no, that's type 2, my bad. That's type 2. I had the right reasoning, but wrong. That's wrong, type 2.
Let's see, where was that page? The 230. Yeah. Oh, by the way, here's the page 231 is the type 1, type 2 error stuff. Like this is what should go in your reference sheet for alpha and beta. But here it is. If we do not reject HO, the only type of error we can make is a type 2 error. If we do reject HO, the only type of error we can make is type 1. So had we made the wrong decision here, it would have been a type 2 error. Okay. That's all 3 things. Your job now is to practice them and be able to do them completely on your own. So, so you've got this question here to work on for the 033, and then for the 133 worksheet, we've got these. So let's do a vote. Which did you feel is the most difficult? Confidence intervals, hypothesis testing, how many, or verify the conditions. Those are the 4 types of things you need to be able to do. Which of those do you think you need the most help with?
I would say I've had so much practice on the hypothesis testing that that's the least. Like I wouldn't need help with that one, I guess.
Same. I'm very good with the hypothesis testing. That 2 sample thing just threw me off a little because I missed class yesterday, but I'm good on it now.
Okay,
So
let's do
what were the
714
other
then.
options?
Let's do 714 because it combines all the other things. So let's try this problem. I've had too many cups of coffee, so I got to run to the bathroom, but I'm sure you don't need to know that. But let's start here first. So page 714. First, make sure you identify what is it you're being asked to do. And there's actually 2 of those 4 items in this problem that you're being asked to solve. And when you take the final exam, there's a good chance you're going to see a problem that looks exactly like this. So let me give you 5 minutes to practice, and let's see what happens. Set a timer for 5 minutes. Okay. That was 5 minutes. How'd y'all do with A?
So
I-
I know p hat equals x over n, and we're trying to find x, so yeah, so 700, 600, and then 588 is what I got. Oh,
Correct.
wait, how did you do that?
Ooh.
Oh,
'cause it's
for
that
like
A.
the
I
percent.
did, I did
Okay,
it backwards. I put the X as the percentage. So then
That
should we should have multiplied that.
You're right that
oh,
this,
oh,
P
okay.
times N.
I
okay.
just put,
I
I
messed up.
just put 588 as the p hat.
no worries.
So that's, okay. So the p value is just like the percent put into a
He
decimal.
has- Yes,
Okay.
it's the sample proportion. And so you were given that, right? In this previous problem, you were given, it was the same thing. Here was your p hats, and here were your n's. And we had to use those to find the x's. So this was the same setup, just kind of how it was organized was a little different. Sometimes we give you the x's and the n's, and then you're asked to calculate the p hat. In fact, your project, your chapter 10 project, your chapter 9 project did it that way. Because your x's were the colors that you counted out, and your n's were the total, the sample size. Okay, how'd you do with the conditions? Do you have 7 things written down? So C1,
Random is given,
you can just write that once.
yeah.
Um,
Independent sampling is 2 groups measured once.
Good.
And then independent, I did 700 is less than 0.05 times all male, and then 600 is less than 0.05 times all female drivers.
Good. This is-
Driver, it has to say drivers, I'm sure. That's
Yeah,
why.
you're probably right, because. Good. This is one of those times we didn't give you the population size. Okay, and then how about for normal?
The n times p1 times q1 is greater than or equal to 10, so 700, yeah, times 5.8. Oh, makes sense.
Because remember, Q is 1 minus P. Good. Again, it's not really anything new. It's just you have to do it twice, which is kind of tedious, and also like can make you think it should be something different. Okay, good.
Can you make your screen bigger? I want to make sure my numbers are right. You have your split screen. There we go. Thank you.
You are most welcome. It would help. I don't have my like writing tool today either, so I'm writing with a mouse. Although I suppose it doesn't look too much different.
Nope, chicken scratch looks good today, Eric.
Love it, Laura, love it.
Oh boy. Did you all get the confidence interval?
That's where I ran, that's as far as I got before I ran out
Same.
of time.
Okay, let's just do that for the sake of time. Let's just do that together. So, same spot as hypothesis testing, right? Stat, proportion stats, 2 sample with summary. Just as a reminder, this is in your reference sheet material. When it does, let's see, confidence intervals are all on the same page. It's right here. Confidence intervals for 2 populations, all on 1 page. We were doing a proportion. Here's the formula, don't worry about it. Here's the calculation of the point estimate, don't worry about it. Here's really what you need from this reference sheet, and that is where to find it in StatCrunch. Here were those conditions you were writing out too, so that's another spot. But note, it is a little different than hypothesis testing because we're using the sample values for the normal condition, whereas in hypothesis testing, you're using the p-hats, the assumed parameter values. Although for, I guess not for this one. Okay, so same thing as what we just did. We put in the X's. You just have to be careful that you're matching what goes with what. Notice we're told to do male minus female. We did male as number 1, female as number 2. And we need to click confidence interval for P1 minus P2. And we are doing a 90% confidence interval. So we need to change that C level, confidence level, to 90%. And then we're just going to compute that. And all we're asking you to do is write down this lower limit and upper limit. That's it. 4 decimal places. How's that feel for everyone? Is that okay?
That's good,
Yeah.
yeah. So you went to like the proportion to summary, okay, 2 sample with summary, got it, that's what I thought.
Same thing for confidence intervals and hypothesis tests.
Mm-hmm.
Good. Okay, remember interpreting? It's been a bit. Same
We
interpretation
are
step 9. Go for it.
90% confident. The true
True.
population proportion.
So these are a little weird because what it is the true difference in proportions.
Okay,
People use rates between male
so
and
the
female.
true,
Population difference and seat belt usage rates between males and females is within, and you don't have to write it exactly like this, negative 0.102 and negative 0.0508.
and are we supposed to change that to a percent or leave it?
We can change it to 1%. That's fine.
Okay, that's what I like better.
It makes more sense for interpreting. I agree with you. So, you could toss in here the true population proportion difference or difference in proportion. So I guess it's there. You could change rates to proportions if you wanted. I just use rates because that's what's being used here. And I guess this should really say male and female drivers. And I guess this should really say within, right? No.
Is within, like, can I say between? That's what I'm used, is that
Oh, yeah,
different?
that's better.
Okay.
Within is usually used if you write interval in interval notation.
Mhm.
Note with the negative numbers, it looks a little weird. We tend to write the smallest number first and the largest number second. This looks larger if we ignore the negative sign. Oh boy. I won't be super picky about that. All right, the big question then. The CDC claims they're different. Do we have support or contradiction for that claim based on our confidence interval?
Well, it has to be 0, right? 0 was the number, so that means that it would contradict because those are not within the parameters, right?
Opposite reasoning, correct criteria. Because 0 is not in there, it supports. Does that make sense?
Yes, I'm gonna keep saying it backwards, though, I can promise you that.
Fair. Keep in mind, we're doing a subtraction, and if the numbers are the same, they'll equal 0. If they're not the same, they'll equal some other number. So because there isn't a 0 in between, we're saying when we do the subtraction between the two proportions, all the possible options for the population difference are negative values. So there's a difference between them. The CDC is correct. And based on the way the subtraction is going, because it's male minus female, females are wearing their seatbelts at a higher rate than males. Almost up to 10% more. Good. Okay, so we only got 5 minutes left. You do have some stuff left to do here. There's a practice hypothesis test here and another practice hypothesis test here. So there's 2 tests. And then there's another, like, can you read the output for the confidence interval question, just like we did at the beginning, and another how many question. I would like you to try these and then bringing them to class on Wednesday, we can start those. Go ahead, Reagan.
So the due date for the chapter 10 project is this week. Is that do you want us to try that on our own?
Yeah.
Or
You have the data set, right?
I don't know what
Count your
the chapter
candies.
10 project is all about. Oh, the candy, yeah.
So yeah, try that out. It's chapter 10. It's the single proportion. I would say bring those. What is today? Is today Wednesday?
Yeah.
So Monday, we'll look at questions on this, and you can bring that project questions if you don't get
Okay.
it.
We can change that due date. We
Yeah.
can change it till Monday.
The crazy thing is there's only 2 Sundays left. And we're done.
I'll change the due date to Reagan so that it can be due on
Yes,
Monday.
please,
Okay.
because it'll keep
I know you
notifying me on my
don't-
phone
Yeah.
I know.
and
I
give
know
me
I just
severe
don't-
anxiety.
Yeah,
I
I know
know
you guys don't count it late, but like it'll have the little bubble that says late. I'm like, no,
I will
you don't
change
do
the
late
due
work.
date. I'll change it. But try it, you guys, because I think you guys will be able to do it. So try it, but yeah, bring questions. We can look at it Monday. I mean, I would say I might have time tomorrow, but I'm doing 11-2. I might not.
And all that's left is 11-2 and 11-3, and they're both, one is dependent sampling with means, which is just doing chapter 10, because you turn the data set into a single data set. The other is independent sampling with means. So it's what we did here, it's the same as this, the 4 questions. Verify how many, actually, we don't do a how many with means. So it's just verify confidence intervals and hypothesis tests, those three things. And the formulas are a little different, like you're gonna go in StatCrunch to T-stats and either it's gonna be paired or two sample. That's it. So really, you know everything. It's just a little bit other language in there. And like we said Monday, the key is, are you working with a mean or a proportion? Finding those differences. So I think we're there, y'all. We're gonna do it. We only have 3 133 class periods left. Is that correct? 1, 2, 3, and then it's the final exam, December 14th. And you have 1, 2, 3, 4 033 class periods left. So your last 033 will be December 13th. You wouldn't have it on the 14th because, or the 17th.
No,
Yeah.
15th.
15th. Right, 15th is your last one. You won't have a class on the 17th because
No, we won't have it on the 15th. Our last one will be the 13th, right?
okay, let me just, here we
Think
go.
you need-
Yeah,
you could-
so your
yeah.
class 13th, the 15th, you wouldn't need to meet because you're taking the final exam here.
Perfect.
Are you gonna like do overall basic review with us before we do this exam, or are you just taking questions?
That is the goal for the 12th. So what I would like to see happen, try to have everything turned in on the 11th, so you have nothing left on your plate. I would even like to see the sample final exam done on the 11th. And then the 12th, we go over that and make sure you have correct answers on it.
You guys, I actually will be doing 11-2 tomorrow, 11-3 on Tuesday. So I can start some review on the 8th. And then I'll have review on the 13th as well.
Yeah,
And
so
I'll
we'll
be-
have,
I'll be-
we'll have
Perfect.
like,
That
yeah.
would be awesome.
Yes. So we're gonna have 3 days of review. Okay, we'll let Eric get to his class. Eric, I'll be on for a little bit tonight, but I am flying back to Michigan tonight.
no worries.
I'll be on for a few minutes.
Safe
Sounds-
travels, Cindy. Have a good day, everybody.
Yeah,
Bye,
I'm gonna
everyone. Great
leave
work.
this at 85 degrees that I'm sitting in right now.
Going
Yeah,
back to the
yeah,
20s.
You're leaving it. Ha ha. It's windy here.